Hello everyone, this is Dr. Savitha M. In continuation with my discussion on nanomaterials, module 5 of VTU syllabus. In this video, I shall be discussing on synthesis approaches, SolGel method, precipitation method, chemical vapor deposition method. All these are coming under synthesis of nanomaterials. Okay, so these all these videos on all the topics I have uploaded in the YouTube channel, My Intuition. Kindly like and subscribe. Now, nanomaterials, as we have now understood what nanomaterials are. Let us recall any material in the scale of 10 to the power minus 9 to 10 to the power minus 7 meters are called nanomaterials. These materials can be synthesized, and this video is about the synthesis, different methods. Okay, there are two approaches. One method is bottom down process, another one is top down process and bottom up process. Okay, see, now let us discuss what it is. Right now, top down process means you have a big material, bulk material, you powder it, that means you cut it into smaller pieces, which will be of the size of micro size. Then again you powder it, you get the nanomaterials. That means from the big you get the smaller ones. That is top down process. Okay, so but how do we cut it into smaller pieces? We need to use a lot of very sophisticated instruments. Therefore, I mean, if a top-down process, top-down approach is adopted for synthesis or preparation of nanomaterials, it is likely to introduce internal stress in addition to the surface defects and contaminants. Because anything we have to use certain very strong beams, which surely will introduce some internal stress in the nanomaterials. The second one is bottom-up process. Okay, now you can see here, bottom-up process means you can see this small diagram, small blocks, gathering small blocks, you can make a bigger one of required size. That is bottom-up, from the smaller one to the bigger one. Bigger one in the sense it is not to the bulk, to the nano scale, whichever comes in the nano scale. See, here you have the nanomaterial. Okay, now for preparation of nanomaterials, first clusters are formed. Initially, atoms or molecules are taken. They are coming together to form the clusters, and clusters come together to form the nanomaterial, and this is in the nanoscale. Okay, we should understand that nanomaterial means it is not single atom or single molecule. It is again a group of molecules or group of atoms, but the size of that is in the nanoscale. Okay, now generally bottom-up process is adopted to grow larger structures, that is gathering atom by atom or by gathering molecule by molecule to the required size. Okay, now let us discuss on the synthesis of nanomaterials. The first method is SolGel method. This is a bottom-up process. Right now, for this synthesis, SolGel method, we should first understand what is a sol and what is a gel. Okay? Sol is a colloidal solution in which solid is dispersed in liquid phase. Okay, here the solid particles is dispersed in liquid phase. Liquid phase will be in the more volume. Okay, next gel. Gel means it is the liquid particle dispersed in the solid phase. That means solid phase will be more and the liquid will be dispersed in that. Okay, so conversion of a sol into a gel and then to nanomaterial is SolGel method. Okay, now in SolGel method, initially a precursor molecule is required. Okay, precursor molecule means reactant. In general chemical reactions, we use the word reaction. Reactants, what are added to get the final product. In nanotechnology, this reactant is named as precursor. Okay, suppose you want to synthesize gold nanoparticle, you should take a reactant which contain gold as one of the component. Okay, therefore that will be the precursor molecule. You have to take a solution of a precursor molecule. In SolGel method, generally water soluble precursor molecules are chosen. Precursor solution is done. Okay, first sol is prepared by taking the precursor molecule, dissolving in the water or a solvent, you get the precursor solution, and then it is converted into a gel. That means in the sol there will be more amount of liquid and less amount of solid materials. Okay, now when you convert into a gel, there will be more amount of solid and less amount of liquid. Okay, so we have to convert a sol into a gel. Okay, and then we have to get it converted into a solid nanomaterial. Okay, now this SolGel process is carried out by with the different series of different steps. That is, first is the preparation of the sol, then you have to prepare the gel solution, then you have to age the solution, and then dry the solution. Drying maybe by dehydration, and then densification and decomposition. These are the different steps. Okay, let us go in detail. Okay, now sol. See, precursor molecule is metal alkoxide. Okay, R will represent the alkyl chain. Metal alkoxide is the precursor molecule. M can be any metal of your choice for which you have to synthesize the nanomaterial. Okay, it is dissolved in water. Okay, the solvent here is water. Now this is metal is, precursor metal alkoxide is dissolved in water, and it is mixed for a very long time. Okay, so continuously it is agitated or it is mixed continuously, and during this mixing process, what happens is some of the metal alkoxide gets converted into metal hydroxide. Okay, and here HOH, water is HOH, one of the H comes and gets replaced here, R gets replaced here. Okay, so you will get alcohol. Okay, now this is the sol preparation. Now this is the sol. See, liquid phase is more alcohol, this everything is in the liquid, only alkoxide is in the solid state. Solid state means now it is in the soluble state. Okay, now you get a sol. Now once you prepare the sol, you have to now prepare a gel. That means the liquid has to be removed, or liquid has to be minimized. Okay, liquid content. How we can do is continuous stirring. When there is continuous stirring, this metal hydroxide and metal alkoxide combine to form metal oxide metal. Okay, so MOM, this will be formed, and everything else will get converted into the alcohol. Okay, now there is more amount of liquid, and this metal, this is the solid phase now. Okay, now when you keep it for aging means just to keep the solution, that is this solution, undisturbed for some specified time. Okay, time duration. During this process, all these hydroxides, that is alcohol, this is volatile in nature and it will evaporate. And as the time passes, the concentration of this, the quantity goes on reducing, and this solid phase goes on increasing. It does not increase, it remains the same, but since this is decreasing, this becomes more dominant. Okay, so you have to age until you get a dense gel. Okay, it should be like a gum. Okay, a very thick gum, because most of the alcohol will be expelled out, or you have to evaporate it. It will get evaporated. Okay, but still there will be alcohol molecules. There will be some solvent molecules also, but you will be getting a very dense gel. Okay, once you get a gel, that you have to now to get the nanomaterial. Suppose you want this nanomaterial, you have to break the bonds, you have to expel out this oxygen, and this metal should be in the nanoscale. Okay, so for this, once you get the dense gel, you have to heat it. Okay, thermal evaporation. There are two methods. One method is suddenly you you take the gel and suddenly heat it to the 900 degrees. Okay, so during this time, very rapid drying, you will be using a muffle furnace, and then you will dry suddenly all the at that temperature. If there are any solvent molecules, alcohol molecules, any liquid molecules, everything will escape, and this bonds will break, oxygen will escape, you will get the nanoparticle. Okay, that is one method, and the product you got will be in the is called aerogel. Okay, next is thermal evaporation. Thermal evaporation is also heating only, but step by step heating. Okay, so this method is, the product is called as zero gel. You will be taking the nanomaterial, the gel, and then you will be keeping in the muffle furnace, and step by step you are heating. Okay, that process is called as calcination. So calcination is done up to 800 degrees, step by step. First you heat it for 100 degrees, keep it there for some time, then you increase the temperature for 300 degrees, keep it for some time, then you increase to 500. So whatever has to evaporate at that particular temperature goes on evaporating. So this is step by step evaporation, and finally when you heat it up to 800 degrees Celsius, you will get dehydrated aerogel, zero gel. Okay, so finally this is again heated to a temperature above 800 degrees. If there are any organic impurities, all that will decompose, will get expelled out, and finally you will get a dense stable nanomaterial. Okay, so this is SolGel method. Okay, it follows by preparation of the sol, that is just by mixing, gel, that is just by aging, you get a dense gel. After that, heating, thermal heating, that is step by step heating to get the zero gel, the nanomaterial, and then or sudden heating to get the aerogel. Okay, this is SolGel method. Okay, what is the advantage of SolGel method? Simple and inexpensive equipment is required. You only require stirrer, beaker, precursor, all those things. The general material, general requirement equipments, all those. Then customizable structure. If you want to customize the structure, you can vary the temperature, you can vary the concentration, aging part, all this. Okay, relatively low processing temperature. Then excellent stoichiometry control. You can control the, if you're mixing, you can control the stoichiometry control. Okay, so these are some of the advantages of SolGel method. Okay, next is the synthesis of nanomaterial by precipitation method. Okay, now precipitation method, general name itself tells, precipitation means you have to get it precipitated. Okay, this method relies on the precipitation of the nanometer sized particle from a precursor solution. Okay, we have understood that precursor solution means it is the reactant solution which contains the metal, or which contains the reactant from which you have to prepare the nanoparticle. Okay, that precursor solution is taken in the soluble state. Okay, and that is solution state. Okay, then you will be adding certain reagent, generally a base, which will make that metal to precipitate out. Okay, now that is precipitation method. The precursor molecule, a precursor solution, precursor can be inorganic metal salts like chlorides of the metal, nitrate, metal nitrate, metal sulfate, etc. These are dissolved in the water and to form a uniform solution. Okay, now once you prepare a uniform solution, then you add, you precipitate out the metal in the form of hydroxide by adding suitable reagents. Okay, this can be precipitation can be done by using certain chemicals, which is chemical precipitation method, or by green synthesis. Green synthesis means you will be using certain plant extracts. Okay, so now let us see this. For an example, we will be taking the synthesis of calcium oxide nanoparticle. Okay, for that calcium, copper, not calcium oxide, copper oxide nanoparticle. Okay, copper nitrate, cupric nitrate solution, salt is taken. It is dissolved in water. So cupric nitrate solution is a precursor solution. Now this is in the solution. Okay, now this solution, let me just first explain chemical synthesis. This is the sol now. I mean, this is a solution now. This solution is continuously stirred. For the temperature should be maintained at 85 degrees, and it is continuously stirred with for sodium for 24 hours, and sodium hydroxide should be added. Sodium hydroxide solution is added drop by drop. Okay, so it is not adding continuously. I mean, it is not adding once at a time. You should add drop by drop. It takes some time. Okay, after it is mixed for 24 hours, it is kept undisturbed for some time. Okay, when you stir it, you will get a white precipitate. That is nothing but copper hydroxide. When you add sodium hydroxide, a base, copper nitrate precipitates as copper hydroxide. Okay, now this copper hydroxide is filtered, taken off, and then calcined at 400 degrees for 4 hours. You will be getting copper oxide nanoparticle. Okay, now what is the size of this nanoparticle? We have to characterize. Okay, the second method is same copper nitrate solution, precursor solution is taken, and it is also stirred for 24 hours at the temperature of 85 degrees. But here, instead of a chemical like sodium hydroxide, here some plant extract is added. Okay, now the reaction is the same. You will get copper hydroxide. Then you have to keep it for some time, and then until all it settles down, then you have to filter it, and the precipitate which is there will be heated to that is calcined. You will get the copper oxide nanoparticle. Okay, this is green synthesis because you are using a plant extract. Okay, this is chemical synthesis because you are using the chemicals. This is precipitation method. Okay, now next one is, I mean, before that, precipitation method, you can use many reagents. We have taken the example of sodium hydroxide. You can also use carbonate, oxalate. All these can be based on the precursor. Okay, this method is relatively simple and widely used for the production of single and multi-component oxide nanoparticle. Okay, using optimized reactions and reaction conditions. Reaction conditions means what temperature should be maintained, how long it should be aged, all these. Okay, the next method is chemical vapor deposition method, right? So the name itself is self-explanatory. See here, chemical is converted into vapor and then it is deposited. Okay, so chemical vapor deposition. See, in this method, there is a chamber wherein a mixture of precursor gas and carrier gas are delivered into the reaction chamber. So there's a chamber where you take the precursor solution. Okay, if you want to make a mixture of nanoparticles, you have to take a mixture solution, precursor solution, and then it is heated to such an extent that this gets converted into the solid gaseous state. Okay, so condition is before it goes to the reaction chamber, the precursor should be in the gaseous state. Okay, now when you go on heating, obviously it will get converted into gaseous state. It is mixed with the carrier gas, both carrier gas and the precursor. Carrier gas is a gas which carries the nanomaterial into the reaction chamber. In some cases, it also takes part in the reaction. Okay, now here in the reaction chamber, it mixes, and due to very high temperature, there the nanoparticle will be formed, and this nanoparticle will be in the gaseous state because temperature is very high. This is taken to another chamber, cooling chamber. In when the entire thing is taken to the another chamber, here carrier gas will be taken out. When it comes to the cooling chamber condenser, carrier gas is taken out for the second entry. Okay, now only the nanoparticle will be going to the cooling chamber where there is a cooling finger. Cool finger is there. Okay, this will be slowly rotating. So as the gas comes here and it goes up, here the temperature is slow. I mean, temperature is less cool. Okay, therefore it condenses. Okay, it is in the gaseous state, it will get condensed into the solid state and it will fall down. Okay, so this is the preparation of nanoparticle by chemical vapor deposition method. Okay, so reaction chamber, the carrier gas and the precursor vapors react to produce the nanoparticle in the vapor state, in the gaseous state. Okay, at optimum temperature. All that we have to find out by, optimize by trial and error method. Okay, next the nanoparticle formed in the reactor is passed to the condenser. Okay, in the condenser, the vapors condense to form the solid nanoparticles. Okay, so chemical vapor condensation. Okay, chemical vapor condensation or deposition method. Okay, so this is the chemical vapor deposition mixture. Again, it is explained here. The mixture of precursor gas and the carrier gas are delivered into the reaction chamber. In the reaction chamber, the carrier gas and the precursor vapor react to produce a nanoparticle, and this nanoparticle formed in the reactor are passed into the condenser. In the condenser, the vapors condense to form the solid nanoparticles. These are the three methods for the nanoparticle synthesis. That is SolGel and chemical vapor deposition and precipitation method. Okay, thank you.